Hello, this is Mike Cassis from the C&E Security CXP team here at Microsoft, and for this microlearning video, I want to talk about how to work with the regular expression engine in Cloud App Security. When it comes to data loss prevention, pattern matching is a mainstay capability that's used across almost every product in the space because it is proven to be effective when you write good rules. Cloud App Security is no exception, and the Regex engine can be used to automate scanning of your cloud files for sensitive content. When users upload new files or modify existing files, they will be scanned against your rule sets. To follow along with this video, you'll need a Cloud App Security tenant that has been connected via API mode to one of the following applications. For this video, I'm using Box, but you can just as easily use Office 365 or any other app we support for file scanning. Next, you should create a few files to test your rules against. And while you don't need to be a master at writing regular expressions, having at least an understanding of the basics will help you follow along. So let's hop over and look at the test files I'll be using in this video. In the lower left corner, you'll see a Word file, which is a fabricated form I created for our person of interest. We'll be matching against her TIN, which stands for Tax Identification Number. I chose this number specifically because this was a use case that came to me from a customer in Latin America, and it's a great example for showing how to match against words, numbers, special characters, and proximity to other information. I took this Word document and I put it in a .rar archive. Cloud App Security can not only scan loose files, but also files residing in archives. And on the right, you'll see my second test file, which is a PowerPoint presentation. Instead of putting the sensitive information in the file, this time I hid it in the metadata as a custom key value pair. Both the presentation and the archive I uploaded to my Box developer account. Next, let's have a look to understand the limitations of the Regex engine so we can be sure we follow the syntax rules. Navigate to Cloud App Security documentation at docs.microsoft.com, and in the search bar on the left, type Regex and click the page title to look at the engine documentation. You will notice there are some limitations to this engine because Cloud App Security is a high-volume engine, scanning thousands of files in a short period of time. Because of the high throughput, we cannot allow broad searches and open-ended quantifiers. I won't rehash everything you see on this page, but I encourage you to have a read to understand what you can and cannot do. Now that we know the limitations, let's take a look at the pattern we're going to write. As I mentioned earlier, this use case came from Latin America, and they wanted a way to trigger based on a TIN, or tax identification number. Let's look at the rules of the TIN pattern. The number starts with 4 letters, followed by 6 digits, and finally an optional 2 or 3 alphanumeric characters. These pieces may be linked together or separated with slashes or hyphens. Because this is the Spanish language, let's also take into consideration special characters as well. Finally, to reduce false positives, let's look for our tax identification number within proximity of something like TIN or tax ID. So with that covered, let's go ahead and start building our pattern. I put some text on the right to act as our sample text. Let's start simple and take care of the 4 letters followed by 6 digits. For the 4 letters, since we also want to cover Spanish characters, I'll use \W for any word character, followed by a list of special characters contained in square brackets. While \W can also handle special characters like these, I wanted to make a point to put them in our pattern to show flexibility. Next, let's cover our 6 digits by putting in \D followed by the number 6 in curly braces. If we go ahead and test our pattern, you'll see that we match the first example, but not any of the others. To start matching more of the examples, we should probably add in that 2 or 3 digit omoclave. Because these final digits are alphanumeric, we need to append \D to our pattern of word characters. Because the CAS engine doesn't support capture groups, we'll put this into a non-capture group using the question mark followed by a colon sign. We'll then specify that we want to see 2 or 3 of these optionally by putting the 2, 3 in curly braces and then following the entire non-capture group with a question mark denoting 0 or 1. We're now matching 3 of our 5 examples, but how about those that have special characters in between each of the sections? For these, we're going to insert some Unicode notation to represent the hyphen, /, and \. Because the Cloud App Security engine supports Unicode, we'll use \U followed by the 4-digit code. Let's drop those 3 different Unicode codes into a non-capture group, and then we'll denote the whole group as optional, again by putting a question mark after it. Now let's copy what we just wrote and put it after the 6 digits as well, since we want it in 2 places in our pattern. After doing one more test, we can now see that we're matching all 5 of our examples. The only thing left to do at this point is add a bit of a proximity search to our pattern so that we can reduce false positives. We'll do this by adding in dot and then 0,9 to look for the proximity pattern within 9 characters of the other pattern we wrote. And finally, for our proximity pattern, we'll create another non-capture group that's just a series of OR statements for things we want to match against. I'll purposefully leave out TID to make sure that that does not match. Once we test our new pattern, we'll see that everything is now matching except for TID, which is what we'd expect. We can finally make our pattern a little more explicit by adding in some pieces to look for the colons, the hash signs, and the hyphens in between something like TIN and the number. I would like to mention that the pattern that we just built is not the same one provided to the customer. This is merely an example. Now that we have our pattern, let's go ahead and make it a file policy in Cloud App Security. Here we are on the policies page, so we'll go ahead and click Create Policy and select File Policy. Now we just fill out our policy form. We'll provide a name and a description, and then for our metadata filters, we'll just apply this to files that sit in Box, because that's where we uploaded our files. And for our DLP engine, we'll choose Built-in DLP, and then select Regular Expression, and then paste in our pattern. At that point, all we have to do is click the Create button. Now I've already gone ahead and made this policy ahead of time, so let's review our matches. It looks like both our archive file that contained the Word document as well as the PowerPoint presentation that had sensitive metadata both were matched. Let's review the archive file first by clicking on One Policy Match. If we click the drop-down next to our policy name, we can see the context of the match. Take note of the 2 sections I highlighted. In green, that is our pattern that was actually matched. In yellow, you'll see some hash signs, and those represent any numbers within the context of our match. The hashing of these numbers is a default setting in the policy, but can be turned off. And next we'll review our PowerPoint file that had the sensitive data in the meta tag. Just like before, we see our match in green, and then to the left we see in yellow other tags that were found within the proximity of our match. Content inspection with regular expressions is a great way to scan loose files, archives, and metadata tags for sensitive content, all while files sit in your cloud environments. Governance actions can be automated based on these matches to remove sharing, make files private, or notify users and administrators that corrective action should be taken. And as always, I want to thank you for your time, and I hope you found this video useful. And I encourage you to join our CXP security community. You can see technical previews, speak directly to our engineering teams, myself included, and ultimately help influence our product direction. For more information, visit aka.ms/security community. Thank you and have a great day.